Hello everyone and welcome back again. Today I bring before you an interesting question on Surds. This is Paragon Pathfinders, and on this platform we make science fun and exciting. Without further ado, let's solve this question together. The question reads, given that 2 root x plus root y over 3 root x minus 2 root y equals 18 plus 7 root xy over 6. Find the value of x and y. The question is, how do we solve it? Well, it's really very simple and easy to solve. All we have to do is to begin with the left-hand side. Why? Because the left-hand side has irrational numbers, and we must make sure that we rationalize the left-hand side to remove these square roots from the denominator. It is not proper to leave the denominator of a fraction in surd form. Okay, so we have to make sure that we remove these square roots from the denominator. You can see that this one does not have a square root here, so it's already rationalized. But for this one, we have to rationalize and then compare. Since they're equal, rationalize and then compare to find the values of x and y. Now let's do that very quickly. Here I'm going to say solution. So we say rationalizing. Okay, we copy the left hand side down. So we have 2 square root of x plus square root of y over 3 square root of x minus 2, again, square root of y. So how do we rationalize this expression? Well, we're simply going to multiply the top and the bottom by the conjugate of the denominator. This is the denominator. And since we have this sign, which is a negative, in between, we're going to change it to a positive, and that becomes a conjugate. So we say we multiply, we have 3 root x. Okay, so this sign now becomes a plus, plus 2 square root of y over, and again, we also have to multiply the denominator. So we have 3 square root of x plus 2 square root of y. So we're basically multiplying everything here by 1. You can see if you divide these two, you just get a 1. So we've not changed anything yet. Now, next up, we can now multiply them out. So we have 2 root x times 3 root x, or we can just say 2 times 3 is a 6, and then root x times root x is root x. We have all squared, right? So we have root x and root x, they're just the same. So when you multiply them, you get root x squared. Again, we have 2 times 2. That gives us a 4. Again, root x times root y gives us root xy. Okay? Now, good. And then for this one here, we have root y, okay, times root x, or 3 root x. This gives us plus. We have 3 square root of xy. Okay, and lastly, root y times 2 root y gives us 2 square roots of y all squared. Since we have root y and root y, multiplying, it gives us root y all squared. And then we're done with the numerator, so let's now work on the denominator. This is over 3 times 3 is a 9. Root x times root x is root x all squared. Okay, again, 3 times 2 is 6. Root x times root y is square root of x, y. Okay, now again, negative 2 times 3 is negative 6. And then root y times root x, they go under the same square root, and you have root xy. And finally, negative 2 times 2 is negative 4. And then root y times root y is root y all squared. Okay, now we have expanded this. The next thing that we're going to do right now is to collect like terms and simplify. So let's do it up here. First and foremost, I'm going to cancel the squares. So this square cancels out with this. This square also cancels with this. This one here also cancels with this. And lastly, this square cancels the square root. So when you square a square root, it's equal to the number inside or whatever value you have inside. So the square goes away with the square root and we have only the value remaining. So when we cancel this, so we now have x remaining. So this gives us 6x. When you multiply 6 and x, you get 6x. And then we have 4xy plus 3xy. The values inside the square root, the two square roots are the same. So we simply add them together. So 4xy plus 3xy gives us 7 square root of xy. And again, we have 2 times y. This gives us 2y. And this is over. For the denominator, we have x remaining after the squares cancel out. So 9 times x is 9x. And then here we have 6 root xy minus 6 root xy is actually a 0 because you can see, just like when you have x minus x, that gives you a 0. So one is a positive and the other is a negative. So that gives a 0. These ones we can cancel them out and then we have negative 4 times y gives us 4y. Okay, so let me just rearrange them. So we have 6x. I'm going to take the 2y, so we have plus 2y. Then lastly, plus 7 square root of xy over 9x minus 4y. So this is the rationalized version. This one here is the rationalized version of this. Okay, the original one we started with has been rationalized, and this is what we've gotten. Now, having rationalized this now, you can see that there is no square root underneath. We can now compare it or equate them together to see what we're going to get. So I'm going to say equating. So when we equate them, this is the left-hand side, the rationalized part. We have 6x plus 2y plus 7 square root of xy over 9x minus 4y. And this is equal to, so we equate this to this one here, which we had initially. Okay, since they're equal, we also have to equate them back. And this is equal to 18 plus 7 square root of xy over 6. Okay, now what do we do at this point? If you look at this, you discover that logically, right? So this equation has two parts. It has a rational and rational parts. You can see 7 root xy and 7 root xy. These are the irrational parts, while 6x plus 2y and 18, these ones are actually rational. So what we do right here is, since we are equal, logically, since they are equal, it means that the rational part equals this one. For example, the rational part on the left equals the rational part on the right, while the irrational part on the left also equals the irrational part on the right. Mathematically, a rational number cannot equal an irrational number. So it's not really possible. So since the rational on the left equals the rational on the right, the irrational on the left equals the irrational on the right, what we can do right now is to equate the rational parts and now solve simultaneously for x and y. You can see right here that we have 6x plus 2y. These two are the rational parts on the left-hand side, okay? And this one here is the rational part on the right-hand side. So we can say 6x plus 2y equals 18. And this is for the numerator. And for the denominator, we say 9x minus 4y equals 6, okay? So we equate rational for rational and irrational for irrational. But since we can we can derive two equations by equating the rational part. We can just go ahead and solve the two equations. So when we compare, we have 6x plus 2y is equal to 18. And then this can be called our equation 1. So for the denominator, we have 9x minus 4y is equal to 6. And this is our equation 2. So you see, we compared rational for rational, rational again for rational, and then luckily we were able to come up with this. So an irrational number cannot equal a rational number. It's not really possible. So rational is equal to rational, while irrational is also equal to irrational. So we are going to solve these two equations right now simultaneously. So I'm going to use the elimination method to solve for x and y. So here we have 6x plus 2y equals 18. So we have 6x plus 2y equals 18. And down here we have 9x minus 4y equals 6. If you look closely here, we cannot really eliminate. So all we have to do is to multiply the first equation by 2 to eliminate y in this case. So it's kind of very easy to eliminate y. So what we do is we multiply this one by 2. So this 2 will be distributed across in such that we are going to have 2 times 2y gives us 4y. And then we can now cancel the 4y on top with this one. We now say 4y minus 4y, that gives us 0. And with that, we can be able to solve for x. So let's say 2 times 6x gives us a 12x. And then 2 times 4y is 2 times 2y gives us a 4y. And this is equal to 6 times 18 is 36. And now here we have 9x minus 4y is equal to 6. Okay, so what do we do right now? We can just add the equations. You can see 4y minus 4y equals 0. And then we have 12x plus 9x, and that gives us 21x. Okay, and this is equal to 36 plus 6 is 42. So we have 42. To solve for x, we simply divide both sides by 21, and then these are going to cancel out. We have that x is equal to 42 divided by 21 is simply a 2. And now we found the value of x. So the next thing that we are going to do right now is to find the value of y. So we can either use equation 1 or equation 2 by substituting the value of x into any of these equations to solve for y. For simplicity's sake, we're going to use equation 2 to solve for y. So we say solving for y. So here, whenever I see x, I'm going to put a 2. So this gives us 9 multiplied by 2 minus 4y equals 6. So 9 times 2 equals 18 minus 4y, this is equal to 6. Okay, so I'm going to move the 18 to the other side, and we have minus 4y. Okay, so we have minus 4y. When I move the 18 to the other side, we now have minus 4y equals 6 minus 18. And then minus 4y equals 6 minus 18 is going to give us negative 12. So we have negative 12. And so for y, what do? Divide both sides by negative 4, negative 4. So this negative, they cancel out. We now have that y is equal to, for here, this negative goes away with this. And then 12 divided by 4 equals 3. So this means that x equal 2 and y equal 3. To verify your solution, you can simply substitute the value of y and x into this, okay? Whenever you see x, you can put a 2 here, and whenever you see y, you put a 3, right? Now, when you put these values in here, you rationalize. When you rationalize, you will see that the left-hand side is equal to the right-hand side, and that simply means that truly x is equal to 2 and y equals 3.